In this example, we have the function x squared plus 2, and we want to find the average rate of change as x changes from 1 to 3 and from 1 to 2. So we have two different scenarios that we're looking at here. We have 1 to 3, so meaning the value of x when it's equal to 1, and then the x value equal to 3, and we're going to create a secant line, so we're going to determine the average rate of change of that secant line going from the x value of 1 and the x value of 3. And then we're going to do the same experiment with 1 to 2. So we're going to have a secant line going from x equal to 1 and then x equal to 2. So let's go ahead and do from 1 to 3 first. And I went ahead and graphed this, but it's pretty easy to get the y values that correspond to that. So the average rate of change formula is f of x sub 2 minus f of x sub 1 over x2 minus x1. So what we need to do is get f of x sub 2. So that's going to be taking 3 and 1. Well, we got to get f of x sub 2, f of x sub 1. So that's taking 3 and 1 and getting these ordered pairs. So let's just first, I'm just going to do this off to the side here. Let's get 1, so the x value of 1. 1 squared is 1. 1 plus 2 is 3. And then the x value of 3 is going to be 3 squared is 9. 9 plus 2 is 11. So this is going to be my x sub 1, y sub 1 point, and this is going to be my x sub 2, y sub 2. So f of x sub 2 was 11, minus f of x sub 1 is 3, over x2 is 3, minus x1 is 1. 11 minus 3 is 8, 3 minus 1 is 2, 8 divided by 2 is 4. So if I were to draw in the secant line, and I'll make my best effort to draw in a line. Let's just kind of cheat here. I'll use that tool here. No, it's not too good, but get a pretty good idea there. There's our secant line from when x is from 1 to 3. Oh, still on the line function. So let's go from 1 to 3 for this one. So now we want to do 1 to 2. So same experiment. We already have the x value and y value for 1. Let's now get the x value and y value for 2. So this one's going to be 2, and then 2 squared is going to be 4. 4 plus 2 is 6. So 2, 6. So this is going to be our new x sub 2 and y sub 2. So y sub 2 is going to be 6 minus, and we're using the ones here, so 6 minus 3 over 2 minus 1. 6 minus 3 is 3. 2 minus 1 is 1. So we just get 3 for our average rate of change as x changes from 1 to 2. And let's now draw in my poor secant line here. So this is going from 1 to 2. So that would be from here to here. It's kind of hard to see. But you see what's happening. As we take this x value closer and closer and closer and closer to that point that we're starting at, this x value of 1, as we keep in drawing these secant lines, and just draw an infinite amount of secant lines, we're going to then get that tangent line at the x value of 1, meaning it's a line that only touches the graph when x is equal to 1. That's going to be our tangent line going right through there, and that is going to be found by taking an infinite amount of secant lines. So in this example, you can see when we start from 1 to 3, we have the slope being 4. So the average rate of change from this point to this point was 4. So the slope of the line is 4, and then as we get closer, that slope gets a little bit lower, meaning that line is going to start to flatten out a little bit because that slope is going down. So it goes down to 3. And if we were to get another one, and you could do this as many times as you'd like, but if you were to get another one, let's say we did 1 to 2. So let's say we did 1.5. It would just get a little bit lower, and then 1.25, 1.10, 1.01. You know, it just, as you just keep on getting closer and closer to x value of 1, you're then going to get the slope of that tangent line. So that's what average rate of change helps us determine.